Bismillahirrahmanirrahim. Assalamu alaikum, boys and girls. Welcome back. Welcome back to another new class of distance learning program. So, my dear students, today it's Thursday, the 26th of November 2020. So, we, all the teachers and the school administration, we all are here in the school to facilitate you guys. So, my dear students, we really need to understand this fact that our country, Pakistan, is going through a very critical phase. And we need to play our role to make it a better place. So, my dear students, today, before starting with our regular lesson, I have just a small clip, a 2 minutes clip. This is a message from our Qaid-e-Azam, Muhammad Ali Jinnah. After this clip, we'll start with our regular work. So here it is. Here it is.
और बहनों, पाकिस्तान हासिल करने के लिए हमने बहुत कुर्बानी की है।
नई सुबह का आगाज सबकी हो एक आवाज, जब काम से हो थकन फिर छेड़े कोई सा और ऊंची अपनी हो परवाज। है कायद का फरमान, ये प्यारा पाकिस्तान आगे बढ़ जाएगा जब मिलके करेंगे काम। काम काम काम, दिन रात करे हम काम, जब काम से थक जाए तो और करे हम काम। काम काम काम, दिन रात करे हम काम, जब काम से थक जाए तो और करे हम काम। ये मुल्क हमारा है, हमें जान से प्यारा है अपनी ये पहचान। ये मेरा पाकिस्तान, चाहत के धारों में, नदिया के किनारों में, हर बच्चे का अरमान, मेरा दिल मेरी जान। मेरा पाकिस्तान, ये मेरा पाकिस्तान, मेरा पाकिस्तान, ये मेरा पाकिस्तान।
So, my dear students, this is my Pakistan. This is your Pakistan. In this situation, in this crisis situation, smart lockdown, we cannot just sit at home. We cannot just sleep and enjoy winters. So, my dear students, it's a huge responsibility on our shoulders. We need to play our part. We need to play our role. So just think about it. So we need to learn. We cannot stop learning. So, my dear students, we have been discussing chapter 12 of your maths book 3, area and volume of similar figures. And previously, in the last lesson, we started with the areas of the similar figures, and we finished with exercise 12A. I did few of the questions with you guys, and I'm sure your respective teachers in your respective schools, they have done the remaining questions. So today, we will be starting new exercise 12B. This is about volumes of similar figures. So before starting with this, I'll just give you a quick recap. Okay, whatever we have learned earlier in the previous exercise. So dear students, previously we learned about the ratio of areas of the two similar figures equals to the square of the ratios of the two corresponding legs, right? So we learned this formula for that. A1 upon A2 equals square of the ratio of their corresponding length. And we worked with this, and we did the first exercise. Today, in this exercise 12b, we will be learning about the volumes of the similar figures. So our learning objective for today, by the end of this lesson, you will be able to solve the problems using the relationship between volumes of similar solid. So boys and girls, the formula is, if two solids are similar, then the ratio of their volume is equal to the cube of the ratio of the corresponding linear measures. And the ratio of the mass is equal to their volume. So boys and girls, we will be using that the ratio of the volume equals to the cube of the ratio of their corresponding lengths. That is V1 upon V2 equals to the cube of L1 and L1 upon L2. Or you can express this in terms of masses as well, that you have masses M1 upon M2, the ratio of masses equals to the cube of the ratio of their corresponding length. So remember, when we were doing areas, we know that we always express the unit of areas as either centimeter square or meter square. Likewise, we have the unit of volume as meters cube or centimeters cube. So here in these two formulae, we have the ratio of volumes and the ratio of masses. So we have cubes, the ratio of the cubes of the corresponding lengths. Previously, we were dealing with areas, so we have square of the ratios of the corresponding lengths. So the only difference between areas and the volume is that in areas we have the squares, the ratios are in terms of squares, and in the volumes we have the ratio of the corresponding length in terms of cube. This is the only difference. So let's start our first question. Find the unknown volume of each of the following pair of given similar solids. So we can see there are two cuboids given to us. The volume of the first cuboid V1, it's unknown. The volume of the second cuboid, that is the smaller one, it's given to us as 12 cm cube. The length L1 of the first cube is 12, the length L2 is 6, so we can label it accordingly. This is L1, this is L2, V1 is not given, V2 is given, so we can write the formula as V1 upon V2 equals to the cube of the ratio of their corresponding lengths. So now we want to plug in these values which are given to us. V1 is unknown, so let V1 be V1. V2 is 72 equals L1 is 12 upon L2 is 6 whole cube. So we can simplify the bracket first. 6 1s are 6, 6 2s are 12. So boys and girls, we can simplify the bracket. 2 cube is 8 and 1 cube is 1. So we can take the cube of these. So the cube of 2 was 8, cube of 1, it's 1. So now we have unknown V1. We simply need to cross multiply. V1 equals 8 multiplied by 72. You can use your calculator to get your answer. 8 into 72 is 576 cm cube. So this was a very simple question. Hope it's clear to you guys. We have simply used a formula. The ratio of volumes of the two similar figures equals to the cube of the ratio of their corresponding lengths. So let's move on to the next question, boys and girls. So again, we have another question. You can see there are two cubes given to us. There are two cones given to us. The volumes are V1 equals 16 cm cube, V2 equals 54 cm cube. The slant height of the cone is given to us as L1 equals to 6, and L2, the slant height of the other cone, it's not given to us, that is unknown. So we're going to use the same formula, ratio of volume of the two similar cones equals to the cube of the ratio of their corresponding lengths. So we just need to plug in these values. V1 is 16, V2 is 54 equals, L1 is, the slant height is given to us as 6, L2 it's unknown, V, so whole cube. Now we can see if we can simplify numbers on either side. We can simplify a 2 8 is 16 and 2 27 is 54. So we have 8 upon 27 equals 6 cube. 6 cube is 216 over v cube. So my dear students, what is unknown? The unknown is v. It's v cube. So we cross multiply the two numbers on the other side. We have 8v cube. I'm writing it here. 8v cube equals 27 into 216. So we cross multiply 8 on this side. 27 multiplied by 216 upon 8. You are allowed to use calculator in this. You can do the needful simplification and you will get your answer as v cube equals to 729. Now, my dear students, you can see that b is having a cube. We were asked to find out the value of unknown v, but it's b cube, so we need to take cube root both the sides. So we'll take cube root both sides, taking cube roots both sides. So we have now the cube root of v equals the cube root of 729. You are allowed to use your calculator. So finally, we have a result. V is equals to 9 centimeters. I hope this makes sense and you have learned the concept. We have simply used the formula ratio of volumes of two similar solids equals to the cube of the ratio of the corresponding lengths. So let's move on to the next question. So dear students, this is question number 8 of exercise 12p. Two similar solid candy canes have heights 4 centimeters and 7 centimeters. Find the ratio of the total surface areas of the candy canes. Given that the smaller candy cane has a mass of 10 grams, find the mass of the larger candy cane. So the first part, we are saying that there are two similar candy canes. If I try to draw these candy canes for you guys, these are something like this. The smaller one and the bigger one. What are they saying? They have the height as 4 centimeters and 7 centimeters. All right. Find the ratio of the total surface areas of the candy canes. So what are they asking us? It means that H1 is given to us as 4, H2 is given to us as 7. So we're going to use the formula as A1 upon A2. The lengths are in terms of height, so we can use as H1 upon H2, the whole square. Remember, when we have ratio of areas, we have the whole squares. And we have the ratio of volumes, it's the whole cube. So be careful in this. So let's plug in these values. H1 is 4, H2 is 7. So what we need to do, we simply need to open the brackets by squaring the two numbers. So we have 4 4s are 16, 7 7s are 49. So the required ratios are A1 ratio A2 equals 16 ratio 49. This is your answer. Ratio of areas of the two similar candy canes. All right, boys and girls. So this was part 1. Now, what is part 2? In part 2, they are saying that given that the smaller candy cane has a mass of 10 grams. Now, let the mass of the smaller candy cane be M1. Let M1 be the mass of the smaller candy cane, M1 that is equals to 10 grams. Find the mass of the larger candy cane. So they are asking us find the mass of the larger candy cane. So we're going to use the formula in terms of masses, M1 upon M2 equals H1 upon H2 the whole cube. So what is unknown? M1 is being given to us as 10. We need to find M2. H1 is already given to us. H2 is already given to us. So we'll simply plug in these values. 10 over M2 equal H1 is 4, H2 is 7, the whole cube. So we can open up the bracket 10 over M2 equals the cube of 4, 4 4s are 16, 16 4s are 64, and the cube of 7 is 7 7s are 49, 49 into 9 is 343. So boys and girls, again we need to do the cross multiplication. So we have 10 into 343 and bring this 64 on this side equals F2. You are allowed to use your calculator, boys and girls, so you can do the needful calculation. 10 into 343 divided by 64, so you can simplify it and get your answer in decimals as 53.593. You are usually asked to express your answer correct to 3 significant figures. So go to round out these numbers and your answer will be M2 equals to 53.6 grams. So this is how you calculate the unknown mass by applying this formula M1 upon M2 equals to L1 upon L2, L1 upon L2 the whole cube. So boys and girls, this is all for today. Hope you enjoyed the lesson today. So what did we learn today? We learned that if two solids are similar, then the ratio of the volumes is equal to the cube of the ratio of the corresponding linear measures. That is the formula we learned, V1 upon V2, L1 upon L2, the whole cube. Likewise, we can also express in terms of masses as the ratio of masses as L1 upon L2, the whole cube. So, hope your concept is clear. Thank you so much, dear students, for learning this concept. So again, there is a pro tip. You all are advised to do the homework right after this lesson for a better understanding. Leave a response. Have a nice day. Follow all the SOPs. Stay home. Stay safe. Take care. Allah Hafiz.